Every year, millions of people make a fateful decision in which they decide that they will hoist their bodies hundreds of feet in the air. They will then allow themselves to be hurled back down to earth at dangerously high speeds, all in the time to feel the force of gravity. Have you guessed where these reckless people are heading? Your local amusement park to try a phenomenal ride called Drop Tower!
Now, let's begin by looking at the Drop Tower history. One of the most popular amusement park rides in the world is the Drop Tower. Initially, Drop Tower was built after the movie Drop Zone, which was released in 1994. This movie was about stuntmen who would conduct aerial tricks from 30 feet above ground level. Many amusement park rides are made after popular movies, and Drop Zone was no exception. Drop Tower was fashioned after the stunts and the movement of the characters and the thrills they received from their reckless tricks. Let's talk about its structure. A drop tower has several names. These include Big Drop, Scream Zone, and Drop Zone. Regardless of its name, it is a type of amusement ride that is made up of a central structure or tower that moves in a vertical fashion. With most drop towers, the gondola, also known as the seating area, are lifted to the top of the structure. Once they reach the top, they are released. Gravity causes the gondola to fall in a vertical motion towards the ground, and the ride stops once the gondola has reached the other end of the structure. Most amusement parks and carnivals have a height requirement to ensure adequate safety of the riders. As such, riders must be 48 inches or taller.
The Drop Tower is a popular theme park attraction, and as such, there are several of them located all over the world. The fastest drop tower in the world is in Intamin, which is known as the Giant Drop, located in Dreamland Amusement Park in Australia. Giant Drop is 390 feet high and can reach speeds as high as of 84.375 miles per hour. Another famous drop tower is located in Las Vegas. This is the highest drop tower, named the Big Shot, which is located atop of the Stratosphere Las Vegas Casino Hotel. The base of the ride is 921 feet above ground, with the top of the ride at 1,081 feet.
Not all drop towers are created equal. They vary in height, passenger capacity, lift type, and brake type. Most of the drop towers are custom made. There are, however, some that are mass-produced in which the height, passenger capacity, lift, and brake type are similar.
The three designs that I'm going to talk about are the Double Shot, Super Shot, and the Turbo Shot. To start, Double Shot was manufactured by SNS Power. This ride relies on compressed air to quickly push riders up the tower, then gently lower them with a series of air cushion bounces back to the loading platform. This ride is only in USA. The average speed for this ride is 30 to 35 miles per hour, and the height of this tower varies from 80 feet to over 125 feet.
Secondly, Super Shot is another ride that appears at some carnivals. There are only 12 seats per car, and therefore it is much smaller than the amusement park drop tower. The carnival version ascends the tower by cables with passengers facing outwards from the ride. As soon as it gets to the top, it drops rapidly like other rides. On the Super Shot, there is a level of suspense in which the rider never knows when they have reached the top of the ride, which is on average around 100 feet. Metal sheets are constructed above the seats at a curved angle to prevent viewing upwards. The ride ascends extremely slowly and will automatically drop it as it reaches the top. As it descends, the gondola is stopped by magnetic or air-powered brakes. There is a carriage that lifts the gondola to the top of the tower. This carriage stays at the top during the drop, and it comes back down when the ride has finished. Another version has a giant magnets on the gondola and the ride is encased in magnetic force field. The ride is lifted to the top mechanically, but then the ride is dropped and when it's near the bottom, it slows because the gondola passes over giant sheets of pure aluminum, which magnets can't stick to. This ride is the Turbo Drop. This ride is a type of tower-based amusement ride manufactured by SNS Power, similar to the company's Space Shack. The current tallest Turbo Drop ride is known as the Supreme Scream and is located in California. This ride is a vertical drop tower. It uses compressed air to propel a 12 to 14 seat car to the top of the tower at an average speed of 12 miles per hour. The car is held for multiple seconds before it is released, dropping almost to the ground. The compressed air bounces the car back to halfway before it is lowered to the loading dock.
Before we get into the force and the motion aspect of the drop tower, let's first explore the term free fall. A free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. With this said, let us explore what defines the process of free fall. There are two important motion characteristics that are true of free-falling objects. Number 1. Free-falling objects do not encounter air resistance. Number 2. All free-falling objects on Earth accelerate downwards at a rate of 9.8 meters per second squared. Let's take a look at this diagram. Since free-falling objects are accelerating downwards at a rate of 9.8 meters per second squared, this diagram of motion would depict the acceleration of a free-falling object. The position of the object at regular time intervals, say every 1 second, is shown. The fact that the distance that the object travels every interval of time is increasing is a sure sign that the ball is speeding up as it falls downwards. Thus, it is important to remember that if an object travels downwards and speeds up, then its acceleration is downwards. We know that a free-falling object has an acceleration of 9.8 meters per second squared, downwards on Earth. This numerical value of the acceleration of a free-falling object is so important that it has a special name for it, the acceleration of gravity, and it is represented by the symbol g. Recall that acceleration is the rate at which an object changes its velocity. It is the ratio of velocity change to time between any 2 points in an object's path. To accelerate at 9.8 meters per second squared means to change the velocity by 9.8 meters per second each second. The chart here highlights how the velocity of an object in a free fall increases by 9.8 meters per second. Thus, in the first second, an object's velocity is negative 9.8 meters per second, and when an interval of 5 seconds has passed, the object has reached negative 49 meters per second, as it has increased 5 times its rate of velocity over an interval of 5 seconds. The big misconception. So we just covered that the acceleration of a free-falling object on Earth is 9.8 meters per second squared. This value is the same for all free-falling objects, regardless of how long they have been falling, or whether they were initially dropped from rest or thrown up into the air. Yet, we may be left wondering, doesn't a more massive object accelerate at a greater rate than a less massive object? Wouldn't an elephant free fall faster than a mouse? These questions are probably based on personal observations made of falling objects in the physical world. After all, nearly everyone has observed a difference in the rate of fall of a single piece of paper and a textbook. The two objects clearly travel to the ground at different rates, with the more massive book falling faster. The answer to the question is absolutely not. That is, absolutely not if we are considering the specific type of falling motion known as free fall. Free fall is the motion of objects that move under the sole influence of gravity. Free-falling objects do not encounter air resistance. More massive objects will only fall faster if there is an appreciable amount of air resistance present. Now with free fall defined, here's how free fall relates to the drop tower. You may question if free fall relates to the tower. Here's how. When the gondola, the seating area of the drop tower, is pulled up to the highest point of the tower, it is released. It drops down using only one force, gravity. Fall of the cable car and the thrill of the ride is actually caused by the free fall. The drop tower does encounter air resistance, but there is not an appropriate amount of air resistance present to really affect the ride. Let's take a look at some abstract graph representing the free fall of the tower. This position time graph shows the free falling seats in the drop tower. The fall starts with a slow velocity and ends with a fast one. Since free-falling seats undergo an acceleration of 9.8 meters per second, the graph is curved. In this velocity time graph, it shows the free-falling seats undergo the acceleration of 9.8 meters per second squared. This graph shows the object starting at zero velocity and ending with a negative velocity, seeing that it drops down. So to put it in perspective, the free-falling seats are in the state of acceleration, and they accelerate at a rate of 9.8 meters per second squared. So in the end of the first second, the seats would have traveled 19.6 meters per second, and by the end of the second second, it would have traveled 29.4 meters per second, and it would keep increasing until it reaches the brakes.
Drop tower's brakes activate to slow the ride before it reaches the ground.
There are two types of brakes, magnetic brakes and friction brakes. Magnetic brakes. The magnetic brakes slow down the falling seats gently, but quickly, and these brakes don't actually make contact with the seats. The magnetic brakes do not require electricity to get the magnets to work. Instead, it relies on the law of magnetic forces. Let us consider a case study of the ride Giant Drop. This ride uses fixed magnets to stop the acceleration of the seats, in which the acceleration is slowed down by transferring the kinetic energy into heat or electrical currents. This is a reaction process whereby magnets transfer the energy of acceleration into heat or kinetic energy. As a result, the acceleration of the seat is slowed down as the energy is transformed. This is a very fluid process that results in a smooth ride for the rider, since the deceleration is directly proportional to the speed of the seats. Another means of braking the acceleration of the seats on the drop tower is through the use of friction brakes. This braking system relies on special earth magnets, by use of in which they serve to decrease the rate of acceleration the closer the seats get to the magnets. Thus, as the seats become closer and closer to the magnets, their rate of acceleration is slowed down enough for it to come to a complete stop. This is an idle braking system, as it requires no electricity and thus has a less impact on the environment.
Radio.